In this chapter, we are going to discuss about concept of similarity, similar polygon, similar triangle and their properties, and last we are going to discuss one very important theorem, that is basic proportionality theorem, and this theorem is also known as Thill's theorem. So let's start. So here, first of all, let us revise what you mean by congruent figures. Children, you have learnt about congruent figure in your class 7th, in your class 8th and 9th as well. So let us recapitulate. Congruent figures or congruent polygons are the figures, they are equal in all aspects, means they are superimposed image of each other. They are equal in every sense, means all the angles of one shape is equals to all the angles of another shape, and all the measurements are equal. For example, here you can see I have drawn two triangles and both the triangles are congruent. When we are saying they are congruent, means all the three angles of the first triangle are equals to the three angles of another triangle. Similarly, the side of first triangles are also equals to the sides of the second triangle. And you can see we have a circle as well. When two circles are of same radius, they are also said to be a congruent figures. So you have n number of examples. We can say, if I'll take just an example of a biscuit packet, so all the biscuits are there, they are overlapping each other, means they are congruent to each other. But let us see some more examples. Here you can see few pictures I have shared with you. In first case, these are two circles. They are circles, they belong to one category, but they have a different size. So they have same shape but different size. Secondly, you have two squares here. Again, one is the smaller one is the bigger one. So they both are square, they have same shape and different size, and similarly in these two examples as well. So children, such examples where the shapes of a figure or the polygon are same but they have a different size are said to be similar figures. Let us take few more examples. We have two line segments. So two line segments are said to be similar figures. They become congruent only if their measurements are same. For example, if I have a line AB and the measurement of this line AB is say 5 cm, and we have another line segment CD and the measurement of this line segment is also 5 cm, in that case they become congruent. But here you can see they are different, so they are similar but not congruent. Two circles, they have same shape but the radii of the circles are different, so they are similar, not congruent, and we know when the radii become same, then in that category they become congruent. Example 3, you have two squares of the same, they belong to the same category, they have a same shape but the size of the square are different, so they are similar but not congruent. Similarly, two triangles, they have a same shape but different sizes, so these two triangles are also similar but not congruent. Remember one thing very important. From here we can conclude one thing, that all the figures, those who are similar, they all are congruent. But now I am giving you one task. Think about it. Can we say that all the congruent figures are similar? Yes or no? Just think about this and you will get the solution or you will get the answer in our same session only. So with these examples, we can conclude one thing. Let us define similar polygons. Similar polygons or polygons are said to be similar if their corresponding angles are equal and their corresponding sides are in ratio or the corresponding sides are in proportion. So let's see one example again. Children, here you can see we have two diagrams, pentagon ABCDE and PQRST, and suppose they both are similar. So if they are similar, what we can write about them? That all the angles of the pentagon ABCD are equals to the angles of the another pentagon, and their sides are in proportion. When we say the sides are in proportion, it means we are writing the first side of this AB upon PQ will be is equals to BC upon QR is equals to CD upon RS, DE upon ST, AE upon PT. So all the sides of first polygon are in proportion or are in ratio to the sides of second polygon. So these two are the similar figure. Remember, the sign which we use for congruency is this. You have learned this in earlier classes, that when two triangles or two shapes are congruent, we use this symbol. But in case of similarity, when two polygons or two shapes are similar, we use this sign. This is a sign of similarity. So let us do one small exercise quickly. Here you have to just do fill-ups. Number 1, all circles. So the options are congruent or similar. So since all circles are similar, because they are of same shape but different size, so your answer should be similar here. Second one, all squares are similar or congruent. Again, the correct answer will be similar. All dash triangles are similar. Now the options are isosceles and equilateral. So what do you think? Which is going to be here? So we know in equilateral triangle all the sides are equal. So our answer is all equilateral triangles are similar. Last, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in proportion. Now, we will extend our discussion to the similarity of triangles and their properties. So, when two triangles are similar, children, in that case again the corresponding angles of two triangles are equal and their corresponding sides are in proportion. You can see we have triangle ABC and triangle DEF, and these two triangles are similar. So, we can write angle A is equals to angle D, angle B is equals to angle E, angle C is equals to angle F, and when we say that the sides are in proportion, so we can write AB upon DE is equals to BC upon EF is equals to AC upon DF. Remember, the sides or the ratio of the corresponding sides of equilateral triangles are always equal. So children, with this, now let us understand one of the very important theorem of your chapter, that is known as basic proportionality theorem. This theorem is also known as Thales theorem or BPT in short. So what this theorem is, if in a triangle there is a line which is parallel to one of the line or one of the side of a triangle, and it intersects the other two lines at two distinct points, say D and E, then this line divides the another two lines in a equal ratio. That is AD upon DE will be is equals to AE upon EC. So let us understand this theorem. So the things which are given to you, children, you know, whenever we are doing any theorem or any proof, we have to write down all the things step by step. We will write down given, we will write down what we have to prove, we will write down what are the things which we are doing under construction, and after that we will start the proof. So here given are in a triangle ABC, the line DE is parallel to line BC. These are the things given to us, and another, it will intersect AB and AC at two distinct points, that is point D and point E. And what we need to prove, that it divides the lines, the other two lines in a equal ratio, means we have to prove AD upon DB is equals to AE upon EC. This is what we have to prove. In this question, children, we are doing one construction as well. You can see we have to join this line BE and DC. This is under construction. Also what we are doing, we are making EF perpendicular to AB as well as DN perpendicular to AC. So let's start the theorem. So children, first of all, see triangle ADE. What is the area of a triangle? How we will calculate the area of triangle? So we know area of triangle is calculated by using formula half into base into height. For this triangle ADE, you can see what will be the base. Base is AD and height will be AC. N. So put the things in the formula. Area is equals to half base into height. Half base is AD and height is EN. Similarly, also find out the area of triangle BDE. Remember, for this triangle also height is EN only. So write down the things in the formula again, and we will find out area of triangle BDE is equals to half, base is BD and height for the triangle is again EN. This is your equation number 1. In the second, this is the equation number 2. In next step, divide equation 1 by equation number 2. So we will have area of BDE upon area of BDE like this, and this half into AD into EN upon half BD into EN. Children, you can see this half and half get cancelled in the next step, and this EN and EN also get cancelled as they are similar. So what we left with? We left with area of ADE upon area of BDE is equals to AD upon BDB. Say this is your equation number A. You can denote it by any number, say 3 or 4, but I am using here A. Now we will proceed the same thing towards another side. Now take triangle ADE. Remember, in first step also you calculated area of ADE, and here also I am calculating area of ADE, but this time I am taking base AE and height will be then DM. So write the formula half into base into height. Half base is AE and for this height is DM, equation number 3. And then calculate area of DEC, that is equals to half base into height. For this triangle, base is EC and height is again DM. So now divide equation 3 by equation number 4. Again cancel the common things, that is that half and half get cancelled and this DM and DM also get cancelled. So we left with area of ADE upon area of DEC is equals to AE upon EC. This is your equation number B. Now let us see what we are getting in equation number A and B. So children, now you can see, if we'll focus only on this diagram, here both the triangles, they are on the same base. The common base is DE, and it is given to you that this DE is parallel to BC. We have learned one very important property in class 9th, that when two triangles are on the same base and between the same parallel lines, then they are equal in their area. So it means what we concluded from here, that area of triangle BDE will be is equals to area of triangle DEC. So now this is your conclusion from this. Now come back to the situation when you're comparing them. What we got in our equation A and equation number B. So children, here we have proved that these two things are already equal, right? If these two things are equal and here numerator are already equal, so what we will get from here? In your equation number A, this portion is equals to AD upon DB, and this portion from equation B is equals to AE upon EC. So these two things are equal. When two things are equal to the same thing, the things are equal. So from here we will get AD upon DB is equals to AE upon EC. So children, with this we have completed our theorem that when there is a line DE which is parallel to BC and this line DE intersect AB and AC at two distinct points, that is D and E, then this line segment divides AB and AC in a equal ratio, that is AD upon DB is equals to AE upon EC. So this is about the basic proportionality theorem. So children, with this note, we have completed basic proportionality theorem. So let us quickly recapitulate the things which we have discussed. Today, we have learnt about the congruent figures. We have learnt about the similar figures. We have learnt about the similar triangle, their things, how the triangles become similar. And after that, we have discussed about the basic proportionality theorem, which is also known as Thales theorem. In our next session, we are going to discuss about the converse of basic proportionality theorem. Along with that, we will take few examples as well. Thank you so much.